So hey everybody, it is actually Friday, the 25th of February. We had yesterday off for an ice day, so we didn't get to cover this, so we're just kind of picking up where we left off. So in this picture, what are the three subatomic particles called? So let's look. Oh yeah, we got our protons, our neutrons, and our electrons. And which particles are in the nucleus? Well, when you pointed these out, we had the protons and neutrons here in the nucleus. That's awesome. So today we're going to determine the atomic number, mass, proton, neutron, and electron count for an element using the periodic table. You can identify that protons determine the element's identity, determine the atomic mass of an element, and determine the number of protons, neutrons, and electrons in an element. So right here is a periodic table, and the periodic table here is color-coded. You can see it has all sorts of cool stuff, and it talks about all the things. If you remember when they started chemistry, or not chemistry, stars, we looked at gas tubes in the other room through the spectrographs, and these are the things we looked at, the noble gases. So we're going to talk about what the group and the periods are later, but right now I want you to see that they're arranged, and if you're up here in the legend, it gives you some options of what these things are. The next thing is we're going to focus on one element here, okay, is that molybdenum. So this is what you'll find here in the box. Every box will have this. It will have the element's name, its atomic number, which is the number of protons the element contains, and the symbol. Now, the symbols are pretty specific. So some will just be capital letters, some will be capital letters, followed by a lowercase, and then the atomic mass. This is the average mass, and that includes everything. But we usually round up. So this one, because it's 94, we're going to round up to 96. And so here on our slides, we kind of dragged and dropped what we've got here. And then we're going to, so that our atomic number is our number of protons, or, because we have to have the same number of protons and the same number of electrons, so it's either one of those. And that the atomic mass is the mass of the protons and the neutrons here. So if I'm trying to figure out how many neutrons I have, I'm going to take my atomic mass, because that's my bigger number, and I'm going to subtract my atomic number. So in oxygen's case, I would have 16 minus 8 is 8. So that's kind of cool. So the atomic number is the number that indicates the number of protons in an atom. So on your periodic table, if you look, hydrogen's atomic number is 1, so it has 1 proton. If you look at carbon, it has an atomic number of 6, so carbon has 6 protons. So the number of proton identifies the element. For example, 2 protons, helium. 29 protons, copper. Our atomic mass, or our atomic mass number, is the number of protons plus neutrons in the nucleus. So that mass is equals to the protons and the neutrons. So that's that number. Since hydrogen has a mass of 3, it only has 1 proton, so I have 3 minus 1 proton means I have 2 neutrons. So mathematically speaking, the number of neutrons is equal to the mass number minus the atomic number. So a helpful hint is that we call this the Ape Man, that atomic number, proton, and electrons, that these are all the same number. And then over here we have the man, the mass number, subtract the atomic number, and we come up with the number of neutrons. So how do we determine this again? Lithium has a mass number of 3, mass number of 7, because 6.9 will round to 7. We like whole numbers because we don't have decimals. I can't give you a part of a neutron. So 7 minus 3 is 4. So neon has a mass number of 20, because that 180,000th is not significant enough to change 20 to 21. So I'm going to have 20, subtract 10, and then I get 10. So what about electrons? These are equal to the number of protons. So if the electron, and you see that's the E with the, instead of an exponent, it has a negative number, and P is equal to the atomic number. So protons. So I'm going to just So helium has a mass number of 4 and an atomic number of 2. So I have 2 protons, 2 neutrons, and 2 electrons. Kind of cool, isn't it? So how do these balance each other out? In an atom, the number of protons has to equal the number of electrons. So if I have 20 protons present, then I have 20 electrons, so that we balance the charge and the atom is neutral. Now remember, neutrons have no charge. Therefore, they do not have to be equal to the numbers of protons and neutrons. So let's look at this one right here. How many protons? 17. How many electrons? 17, because it matches the atomic number. And then our atomic mass, well, that's 0.4, so we're going to leave that be. So we're going to take 35, take away 17, we're going to have 18 neutrons. Very good. So we drag and dropped this together here on the slides, as you see here. And we filled in these. Now this worksheet is available if you are with us and you are not with us face-to-face. Your makeup will be right here, Atom, Family, Ape Man. And it's a little different than what our friends in class did, but it's the same worksheet. So you have different elements to work on. These are some examples. You can pause and take a look at this. So here's our exit ticket. Whether you're in Miss Drew's room, you use Socrative. If you're in Miss Brown's room, we did a plicker. So how many protons, neutrons, and electrons are there in an atom of scadium? So first thing I'm going to do is I'm going to say, well, let's see here. There we go. I'm going to insert a text box. All right. So scandium has its 44.9 is its atomic mass. So I've got to round that to 45. And I know because of the, so 45 is its AMU. And I know that I have, because of its atomic number, it's 21. So I have protons. I have 21. I have electrons. 21 because I got to equal. So I have to find my neutrons. And that's 45 minus 21 is equal to 24. So let's see, I can do this. I got protons 21, so I got 3, so I can scratch out B, because that's got the 45 there in the protons. Okay, 21 electrons. Oh, gotta get rid of D because that's gotta match my protons. So now I have A and C. Well, if I rounded correctly, I actually have 24 neutrons, not 23. So the answer is C. All right, friends, we hope you had an enjoyable time with us, and we will see you on Monday. We're going to continue to talk about reactivity and the elements. Have a great weekend.